Picture yourself on a sunny afternoon in the park, blowing soap bubbles with your friends. The sunlight hits them just right, and they shimmer with rainbow colors. But as you watch them float away, have you ever wondered, why are they always round? Why don't bubbles come out as cubes, triangles, or hexagons? What hidden rules of physics are at play here? The short answer is surface tension. But that doesn't tell the whole story. To understand why bubbles form into spheres, we need to zoom into the strange world of soap films, air pressure, and the natural obsession of the universe with efficiency. A bubble is essentially a thin film of soapy water wrapped around a pocket of air. This film acts like a stretchy skin. When you blow air into the soapy liquid, the film expands and its molecules arrange themselves to minimize energy. Nature loves efficiency. It always tries to use the least energy possible. And what's the shape that uses the least surface area for the volume it contains? The sphere. That's why every bubble you see ends up round. Think of it like this. Imagine you're wrapping a gift, but you only have a tiny sheet of wrapping paper. You'd want to cover the gift using as little paper as possible. The most efficient way the molecules in soap film can wrap air is by forming a sphere. Cubes and pyramids would require more wrapping paper, surface area, for the same amount of air, which means more energy, and nature says, no thanks, too much work. Surface tension plays the role of the boss here. It's the invisible force pulling every part of the bubble's surface toward the center. This force balances out equally in all directions, and the only way for that to happen is to form a round shape. That's why even if you blow bubbles from a square or star-shaped wand, the film might look cool at first, but the bubble will immediately settle into a sphere once it leaves the frame. But wait, does that mean bubbles can never take other shapes? Actually, under the right conditions, they can. Scientists and hobbyists have created cube-shaped bubbles using special wire frames dipped in soap solution. When you blow air inside, the soap film stretches along the edges of the frame, forming something that looks like a cube. But here's the catch. The surfaces inside are still curved, not flat. The bubble only appears cube-like because of the frame's boundaries. The natural preference of the soap film is to curve into round surfaces. Now, let's connect this everyday wonder to bigger science. The same principle explains why planets and stars are round. Gravity pulls matter equally from all directions, just like surface tension in a bubble. As a result, large celestial bodies settle into spheres. It's the universe's way of saying round is efficient. There's another twist. Bubbles don't just look beautiful, they also reveal patterns of light. When sunlight passes through the thin film, it reflects and refracts, creating interference patterns that make rainbow swirls. That's why bubbles aren't just round, they're little floating canvases of physics and art combined. So, next time you see a child chasing bubbles in the park, remember, those floating spheres are demonstrations of nature's obsession with minimizing energy. They're tiny physics lessons disguised as toys. Every bubble is proof that efficiency and beauty can go hand in hand. And maybe that's why bubbles make us smile. They're simple, fragile, and short-lived, but inside them is a universe of science. They remind us that sometimes the most ordinary things, like soap and air, can reveal extraordinary truths. So, why are bubbles always round? Because physics loves laziness. Spheres are the easiest, most energy-saving shapes in nature's playbook. And that's why no matter how you blow them, bubbles refuse to be anything but round. Final question, if you could design your own bubble shape, square, star, or even heart-shaped, what would you pick? Don't forget to like, share, and subscribe to Wiseuse for more science explained with a smile.